to go to, say, today's folder. Today is the 10th. Is that the 10th? So all we do in this case is to make a very simple program, as simple as it gets. So that way there's nothing to interfere with our understanding of what's really going on. So we say GCC, and we'll specify debug information. Doesn't really matter whether we do that or not. And then we use the program called object dump, and you can use object dump on an executable. And I can't. Or something? Yeah, you have to specify dash something. We can look at a symbol table. That's T. So here we have all the symbols related to this. From assembly language programming, we already know what underscore start is. You guys do remember, for those of you who took assembly language programming from me, underscore start is a symbol defined to become the entry point of the entire program. It does not have to be at location 0 of the .text segment. It can be anywhere, but basically that becomes the entry point of the entire program. And it is very important to the loader to know what location should be the first instruction to execute. And then we want to take a look at some of these names here to find out whether we can look in the clue out of the initialization code. libc start main, I think that is the entry point of the libc initialization code. So I think that gets controlled before your main subroutine gets controlled. The other way to do this is to disassemble the code and see exactly what it looks like. Then we can tell also.
Dash D does disassemble.
Does it? Dash D. So underscore init seems to be the initialization code. It pushes the EBP. Oh, this looks like a regular subroutine to me. Because these two instructions here, push EBP, move ESP to EBP, is a very typical entry code for any subroutine written in C, intended for C. Push EBX is important because EBX is also used. So this looks like a regular subroutine to me. And it calls another subroutine, which is underscore init plus 0 plus C. So it's actually calling, it looks like it's calling itself because the entry point of that is actually here. So what this is doing is trying to determine its location on what is its current PC or program counter. That's how it's trying to do it. That's what it's trying to do.
Because it pushes EBX on the stack, it just pops it off right away.
Yep. Mm-hmm. So this has to be written in assembly or something pretty close to that, or inline assembly, because I don't think you can do it in C. Then it's adding a certain offset to EBX, and then moving this into EDX, test, jump if equal to that location, 9A, which is down here. So it's doing some sort of conditional initialization down here. And then we have, and that's under the .init section. So I'm pretty sure if you track this down, you can find out exactly how everything is initialized. Now, if we try to compile the program, even though this is not a multi-threading program, you can always specify dash p thread. And if we dump out the content again, I think this time it will look a little bit different. I think there will be some initialization specific to p threads in this particular case. No? Yes? Not yet. Or we can just look for grid. Nope.
Dump it into a text file and dip it.
Sorry?
Dump it in a text file and dip it.
Yeah, we can do that. Good idea. Then we go go back and change the program or change the compiling option without pthread, dump it again and say without thread. So there are differences. They're different because the address is different. Well, that's one. I mean, that may not be the only difference. I think there are important differences between those two. I think the without version does not call libc underscore csu underscore init. So that might have something to do with thread initialization.
It does.
Hmm?
It does.
It does? What does?
Well, it's up there a little bit.
Okay, well, let's try to make it a little bit easier to look. Vim div. Alright, so now we're looking at just the differences, just location differences. Oh, okay, right here, frame dummy. This one exists only without thread. The one with thread does not have this.
Oh, there's the frame dummy.
There's a frame dummy. And I think at this point it's completely out of sync. It would just keep complaining forever. So I'm not sure whether this is answering your question or not, but you can actually look into this to find out exactly how things are done. Any questions? All right. The next slide is the first one that. Oh, well, I didn't specify that. That's okay. So this is the first slide that actually talks about programming with threads or pthreads. So in this case, I have an incomplete example, which means that task one is supposed to have something that is useful to do in the body of the function here.
Fork will fork.
Hmm?
Fork will fork.
And then main is the main program. So in this case, pthread underscore t is the type of a pthread, and you have to pound include pthread.h in order to have all those types defined. The first thing I do in this program is to call pthread create. Pthread create takes 4 parameters. The first parameter is a pointer to a pthread type, so it can return back an identifier for the thread it is created successfully. The second one allows you to specify additional parameters of how the thread is created and also additional parameters for the newly created thread. The third one is a pointer to a function. The pointer to the function must have a void pointer parameter type and also must return void. And the last one specifies an object or an address that you will pass to the function when the thread starts. So that way you can actually pass different parameters or information into the thread